Welcome back to Swell Academy. Today we're looking at an example of a system of equations, right? You have two functions, multivariables that are the same, y and x, and these two functions create this system. Now, in the past, we've shown, okay, there's a way to graph both of these and come up with a solution or for both in which y and x are the same for each line. There is some sort of intersection solution for both. But there is another way we can look at these and solve them algebraically. And if you see both functions are equal to y, okay? So, or y is equal to something. And that something we can substitute in this function where, okay, y is equal to y, so therefore 5 plus 3x is equal to 19 plus x. And in setting it up that way, we're able to solve for x, subtracting x on both sides, and subtracting 5 from both sides, moving pieces, 2x is equal to 14, divide by 2, x is equal to 7. And so we have a value for 7, which would mean on this graph their intersection would be 7, and then we can take the 7 and plug back into either function, 3 times 7, 5 plus 21, 26, or 19 plus 7, 26, and get our value for y, which at our intersection of the graph would be there. Now, I have another example, and to show a little wrinkle, little obstacle you may see, because keep in mind in the previous example we had y equal to something. But in this case, we don't have y by itself here. We don't have y equal to something. So when we want to say y equals to y, we can't technically do that. So what we'll do here is we'll subtract the 1 from both sides, and we'll get y is equal to x minus 1. And in doing that, we have, again, y equal to something. And we could take those somethings, negative 2x plus 5 and x minus 1. We can set them equal to each other. And I like to move the 2x in a way to keep x positive, so I'm going to move the 2x this way, and at the same time I'm going to move the number, solve for it, and get my value for x. And again, on a graph, this would mean at 2 there would have been some, those aren't the greatest lines for an intersection, there would have been some intersection of these two lines here for that function. And once I get the 2, what I could do is, again, plug back in like I did on the previous one. And here we have negative 4 plus 5 equal to 1. We have 2 minus 1 equal to 1. Same value for each, meaning our xy coordinate, our solution for this would be 2 and 1. Same if we were to graph that. So, and if I'm looking at this problem, I'm saying, yes, I could set up a graph. I could take my y-intercept, my slopes, and graph this and find an intersection. Hopefully I have some graph paper, maybe I have some Desmos. But when I see a problem like this, I see an opportunity to do some algebra, maybe quickly identify a solution, or maybe check my work on my graph or support and prove my graph and my solution by doing some algebra. So good opportunity here. We call this equal values method. Remember, the more you fail, the more you succeed. Hope this helps. Keep working hard. Sorry for the other little interruption during the video, but I'm sure you got through it. And we'll see you on the next one.